Howdy PreCal, it's Miss Kosh. In this video, I wanted to show you how you can use Desmos to do parametric equations. Now I will say, I was playing with it a little bit ago, I will say that the Casio is easier to work with. But if you don't have a Casio, this is plan B. Okay, so what you'll do is you'll write things as an ordered pair. You'll type them in. So say, for example, we have an initial velocity of, I don't know, my birthday is 6/17. We're going to use that. We have an initial velocity of 6. So then we have to come in, we have to hit alpha and come down to put t. So I'm trying to do 6t, and then I go over to function, cosine. My birthday was 6/17, so we'll use a 17. That's the x component. Remember how we had x was equal to the initial velocity times time times cosine of the angle. That's the x component. And now I'm going to hit the comma and then do the same idea. Use y. Remember with y we had the gravity pull, so it's 1/2 or negative 1/2 g t squared plus v naught t sine theta plus your initial height. Okay. This should not be your first video, so hopefully you've watched the other ones first. Let's say this is in, let's do this in meters just for the fun of it. So the gravity in terms of meters is 9.8, so half of that is 4.9, so it's a negative 4.9. And then I would need t squared plus, we had set an initial velocity of 6. I need my t again. Don't forget the t. That's what I often do. Sine, what was my angle? 17. Close parentheses. Let's have an initial height of, I don't know, 2. Just for the fun of it. Okay, close those parentheses. Well, now this graph does not look like what I expected it to look like. So what I need to do is I need to verify, oh, sure enough, I'm in radians, not degrees. So that I needed to change. And now this looks a little more like what I might expect to see. Now, unfortunately, the Desmos will do, okay, a couple things. First of all, down here, I can put in different t values. So if I put in like 0 to 2 with my t values, then it'll go a little farther until it gets down to, this is where it would be at 2 seconds. The advantage to the Casio is that you can have it evaluate a particular t, like at time t, at time 1 or whatever. This is where my my value would be. Like say I want to know at time 0.5. Well, I can zoom in here, but it won't let me click on it and figure out what that value is. So I can get an idea, but the Casio allows you to be more precise. Let's go back to say 2 so we can see more of that. What we can also do is we could come in and we can type in the y equals, do it in parametric, I lied, in rectangular form, negative 4.9 x squared plus 6x sine, I hope I'm remembering all my details. And then what did I say? I had an initial height of 2. Okay, so with this, if it's in rectangular, wow, zoom. If it's in rectangular form, I can plug in those different values. And so if I want to know, so notice this is saying at time 0.179, it is 2.157 meters tall. What I can do is I can come along and say, well, 6 times, oh, I just forgot the number, 0.179. Okay, so 6 times 0.179 times cosine of 17, that will give, 17, there we go. That will tell me roughly how far down the field I am at this gives me my x value at that time when it's the highest. So if I were to, let's say, or you know what, let's see if it'll graph this. I say equal x. Okay, sure enough, that does appear to be when that parabola is at its highest. So you do have a solution for figuring out, but the Casio, once again, is easier. So say I wanted to do this one. I want to know how far down the field it is when it hits the ground again. I could come in and say, oh, I just forgot it. 8, 4, 2. Okay, that's geometric. Half of 8 is 4, half of 4 is 2. I'm going to remember that. 6 times 0.842 cosine of 17, close that parentheses. Let's set that equal to x also, just so that it draws the line for us. And sure enough, that's where it hits. Oh, you know what? If I put equals x, it no longer gives me the value. Okay, but now we could know that it's gone 1 meter, roughly 1.027 meters down the field when it's at its maximum height. It's gone 4.831 meters down the field when it hits the ground again. So that's not nothing to be able to work through those problems. So good luck, go practice. If you have access to a Casio, you can store these different times and be a little more precise as far as like using more decimals here. Like, well, it only wants to give me 3. So anyway, good luck, go practice, subscribe to my channel. Goodbye.